payment service stopped processing transactions. The server was alive, but all request threads were blocked. Error: Java, util, concurrent, rejected execution exception, thread pool exhausted. The root cause: long polling endpoints held HTTP connections open for 60 seconds each. With 200 concurrent clients, the thread pool was fully occupied by long polling requests. New payment requests couldn't get a thread. Let's break down why this happens and how to fix it. Welcome to TheCodeForge. Before we dig into that production issue, let's cover long polling versus SSE versus WebSockets. Long polling, server-sent events, and WebSockets are three techniques for pushing real-time data from server to client. Long polling emulates push by keeping HTTP requests open. SSE is a unidirectional standard over HTTP. WebSockets provide full duplex persistent connections. Long polling exists because HTTP1 had no push mechanism. The client sends a request, the server holds it open until it has data or a timeout, then responds. The client immediately sends another request. It's not real push, it's a loop that looks like push. Here's a naive long polling server in Node.js. Clients hit poll and block. When push is called, all waiting clients receive the data and reconnect. Note the timeout after 30 seconds to prevent resource leaks. Server-sent events is a standard that lets the server push text events over a single long-lived HTTP connection. The client uses the event source API. It's unidirectional, server-to-client only. That's fine for live feeds, stock tickers, notifications, and log streaming. Here's an SSE server. It sets the correct headers, sends a keepalive comment every 15 seconds to prevent proxy timeouts, and pushes a new event every 2 seconds. The event source API on the client handles reconnection automatically. WebSockets provide a persistent, full duplex connection over a single TCP socket. The client and server can send messages anytime. It's the go-to for low-latency bidirectional communication: chat, gaming, collaborative editing, financial tick data. Here's a WebSocket server using the WS library. It echoes messages and sends a welcome. A heartbeat interval every 30 seconds pings clients. If a client doesn't respond, it's terminated. Without heartbeats, half-open connections leak resources. Here's a rule of thumb: need bidirectional, low latency, and can control the network. WebSockets need server-to-client streaming only and want simplicity. SSE can't upgrade the server or client or need to traverse restrictive proxies. Long polling. This is the same issue we highlighted at the start. Here's exactly why that happened. The payment service used long polling endpoints that held HTTP connections open for 60 seconds each. With 200 concurrent clients, the thread pool of size 200 was fully occupied by long polling requests. New payment requests couldn't get a thread and were rejected with a rejected execution exception. The fix was to move from long polling to SSE with a dedicated event loop using Netty. SSE uses a single thread per connection for writing, not per request. This freed the thread pool for business logic like payment processing. The key change was using a sync I/O instead of synchronous thread per request. Every long polling request ties up a thread for the poll duration. In a synchronous server like Tomcat, 1,000 clients polling every 30 seconds means 1,000 threads blocked. Your thread pool will exhaust, and other requests like payments will be rejected. Always use a sync I/O or a dedicated event loop for long polling. This is the exact mistake from the incident. Long polling ties up server threads for the duration of the poll. Always use a sync I/O or dedicated connection handlers for real-time protocols. Load balancers and proxies have idle timeouts. If your SSE connection sends no data for longer than the timeout, the proxy kills it. Fix: send keepalive pings. For SSE, a comment line every 15 seconds. Without heartbeats, TCP connections can remain half-open indefinitely. The server thinks the client is connected, but the client is gone. You'll leak file descriptors and memory. Always implement ping-pong or a custom heartbeat. The article mentions the 6 concurrent connection limit per domain for SSE, but it's important to note that this limit applies to the event source API in browsers. For server-to-server SSE, there is no such limit. Also, HTTP2 multiplexing can bypass this limit, but event source does not use HTTP2 multiplexing. Each connection is separate. The article mentions that SSE auto-reconnects with last evented, but doesn't show client code. Here's a minimal client that handles reconnection and sends the last event ID. The server must parse the last event ID header and replay events accordingly. The article doesn't mention WebSocket subprotocols, which allow the client and server to agree on a higher-level protocol, e.g., WAMP, MQTT. This is useful for interoperability and can be specified in the WebSocket protocol header. The server must validate and respond with the chosen subprotocol. When debugging real-time issues, start by checking the number of active connections. For SSE, use TCP dump to verify keepalive pings. For WebSocket, use curl to test the upgrade handshake. These commands help identify proxy timeouts, connection limits, and upgrade failures. Let's run through some common interview questions. How does SSE handle reconnection differently from WebSockets? SSE auto-reconnects with last event ID. WebSockets require manual logic. When would you choose SSE over WebSockets? For unidirectional streaming and simplicity, avoid if bidirectional or binary needed. What happens to a WebSocket connection when server restarts? TCP breaks. Implement client-side reconnection with backoff and message IDs. And a few frequently asked questions. What is the difference between long polling, SSE, and WebSockets? Long polling emulates push via HTTP. SSE is unidirectional streaming. WebSockets are full duplex. When should I use SSE instead of WebSockets? When you only need server-to-client data and want simplicity with auto-reconnect. Can WebSockets work through corporate proxies? Often not. Proxies may strip the upgrade header. Fall back to SSE or long polling. To recap, long polling is a hack that scales poorly. Avoid it unless you have no other option. SSE is simpler than WebSockets for unidirectional streaming and gives you auto-reconnect with last evented for free. WebSockets are the only choice for bidirectional low-latency communication, but require manual reconnection and heartbeat handling. Always send keepalive pings to prevent proxy timeouts and detect dead clients. Ready to go deeper? Up next, IP addressing and Anycast, then database replication, then database sharding. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.